we have covered resistive circuit, inductive circuit and capacitive circuit. After that we have studied RL circuit and RC circuit. Now we see the formula based on RL circuit and RC circuit. There are different formulas which are used for solving the numericals. See here, inductive reactance means it is the opposition to the flow of electric current offered by inductor, and the formula for inductive reactance is XL is equal to 2 pi FL. XL is equal to 2 pi FL. And then after capacitive reactance, it is the opposition to the flow of electric current offered by capacitor, and the formula for capacitive reactance is Xc is equal to 1 upon 2 pi Fc. The unit of inductive reactance and capacitive reactance is ohm. Third definition is impedance. Impedance is denoted by letter Z. Here Z is equal to, impedance is the combined opposition to the flow of electric current offered by resistance and reactance. See here, R for resistance and X for reactance. Depend on the circuit, the value of X becomes inductive reactance XL or XC, capacitive reactance. This Z is equal to R plus Jx is a rectangular form, and Z is equal to R angle phi is a polar form. In this small r can be calculated as under root r square plus x square, and the value of phi can be calculated using this formula. Phi is equal to tan inverse x upon r. This is the mathematical method to convert the rectangular quantity into polar quantity. By using calculators also we can convert rectangular form into polar form, and vice versa, polar form into rectangular form. Now see, next definition, power factor. What is power factor? Power factor is power consuming capacity of the circuit. We can say that power factor is denoted by cos phi. Now the formula for cos phi is R upon Z, resistance upon impedance of the circuit, and cos phi is unitless quantity. See next definition. Next definition is active power. In electrical circuit we have seen there are three types of powers. First power is active power, which is real power, and the formula for this power is, it is denoted by letter P, and formula is P is equal to VI cos phi. It is the product of voltage, current and power factor. The unit of real power is watt. Next definition is reactive power. Reactive power, it is the another type of power which is generated by capacitor or inductor in a circuit. This power is imaginary power. The formula for this power is Q is equal to VI sin phi, and the unit of this power is VAR kVAR. Here K means kilo, V for voltage and A for current, and R denotes the reactive power. After that, the next type of power is apparent power. It is denoted by letter S, and the formula for apparent power is S is equal to V into I, and the unit of this power is VA, kVA, MVA. Transformer is designed in this apparent power. Let us see first numerical. In this numerical, a resistance of 50 ohm and inductance of 0.1 Henry are given, and they are connected in series. This series combination is connected to, or it is supplied with 230 volt 50 Hz AC supply, and here to calculate impedance and total current flowing through the circuit. Also we have to calculate the power factor of the circuit. Let us see the solution of this problem. Given terms are R is equal to 50 ohm and L is equal to 0.1 Henry. Henry is the unit of this reactance. Inductive, this L reactance, the value of reactance is L. From the value of reactance L, we have to calculate the value of inductive reactance. So therefore inductive reactance is XL is equal to 2 pi FL, means here 2 pi into 50 into 0.1. This gives the value of inductive reactance, and the value is 31.41 ohm. After that, we calculate impedance of the circuit. Impedance is the combined opposition to the flow of electric current offered by resistance and reactance. So resistance is directly given, and we have calculated inductive reactance by using reactance, the value of reactance. So impedance can be written as Z is equal to R plus JXL, and by putting values, the value of R is 50 plus J as it is 31.41 ohm. This is the rectangular form. We have to convert this rectangular form into polar form. So Z is equal to R angle phi ohm, and the value of R is under root R square plus XL square, means under root 50 square plus 31.41 square. We get the value of R is 50 square plus 31.41 square is equal to 59.04. And phi is equal to tan inverse XL upon R, and the value of phi can be calculated by using formula tan inverse XL upon R. By putting values, XL is tan inverse, the value of XL is 31.41 divided by the value of resistance is 50 ohm. We get the answer 32.13 degree. So we can write as the value of Z is equal to 59.04 angle 32.13 degree ohm in polar form. Thus we have calculated this polar form. Polar form is necessary to do the operations like multiplication and division, and rectangular form is used for doing the operations like addition and subtraction. In current I is equal to V upon Z is equal to 230 upon this. Take here is division, so we have to take the polar form of the impedance, and taking the first value 59.04. By solving this we get the answer. Current I is equal to 3.89 and angle is minus 32.13 degree ampere. We get the value of current as I is equal to 3.89 angle minus 32.13 ampere. Now we see the power factor of circuit. Power factor is cos phi. So by putting cos and value of this phi is, by putting the value of phi is 32.13, we get cos phi as cos 32.13 bracket close is equal to, answer is 0.84. This is the value of power factor of the circuit. Thus we have calculated impedance, current and power factor of the circuit.